All right, today we are starting Chapter 7. Chapter 7 is a long chapter. There is a lot of information in it. So we are going to be breaking it up into, I think, 4 parts. So we chunk up Chapter 7 a lot. So we'll have 7.1, day 1 and 2, 7.2, day 1 and 2. We'll probably be looking at taking a quiz or quest next week. I'll look at the schedule and give you an exact day. But I wouldn't expect that to happen until probably Tuesday of next week. So today we are going to start off with adding polynomials. For our warm-ups, not entirely unlike the homework I gave you over the weekend or after your quest, we are going to simplify these expressions. Part of that is going to be distributing or could be combining like terms. So on number 1, what can we do to simplify this? Good, we can combine our like terms, negative 6x plus 8x. Remember, you always keep the sign that's right in front of the term with it. So this 8x is considered a positive. If we combine negative 6x plus 8x, what do we get? 2x. Why is it not 2x squared?
Because we're not using exponents.
They do have exponents, technically. It's because we're adding and not multiplying. If we were multiplying, then we would change the exponents. If all we're doing is adding, the exponents are not going to change. What else goes with that 2x? Plus 1y, or you could just put plus y. It would be the same thing. Could we make this 3xy?
No.
Why not?
Because there's
2 different variables, 2 different letters. They are not like terms. Very good. Okay, any other questions on number 1? On number 2, what do we need to do to start simplifying this? Distribute. So we want to distribute this negative into the parentheses, which means it gets multiplied to every single term. If you need to think about it as a number, what number would we be distributing? A negative 1. So if you need to see the 1 there, you could put it. But if there's a negative sign outside of parentheses, it's like having a negative 1. So a negative times a negative makes the 3x positive. It makes the 10y negative, so minus 10y. And it makes the 9z positive. So it switches all of the signs. Can I combine anything here? Why not? Okay, no like terms, all different variables. Questions, concerns? Need more time on the warm-ups? Okay. A monomial is an expression that is a numeral, a variable, or the product of a numeral and 1 or more variables. This is a monomial. So we've got room for some examples. So a numeral just means a number. So examples could be things like 5 or negative 162. Those would be just numbers. Those are considered monomials. Could be a variable.
Could be a fraction.
Sure, it could be a fraction or a decimal. So we could have 1/2 or 0.65. Those are all monomials. Could be a variable. What's our most common variable?
X.
X. Could be a different variable like a with an exponent. a to the 5th power. Okay. Could be a product of a numeral and one or more variables. So it could be something like negative 12x cubed. That would have one variable with it. It could be something like x, y, z. Multiplying several variables all together. They could have exponents on them or not. Even something like b to the 6th divided by 5. We would be multiplying by 1/5. It ends up looking like division, but that's still considered a monomial, one term. Questions about what a monomial is? Okay, so it doesn't just mean there's one thing there, like x, y, z. We see 3 different variables there, but they're all being multiplied together. Anybody need more time on this slide? Okay. A numeral is a constant monomial. So any of those examples that we had that were just a number without any variables there, those are constants, meaning they don't change. So the 5, the negative 162, is that what I had? I mean, it could be 10, negative 3.5. These are all considered constants. They don't have a variable. So if you want to add that note, you can. No variable. Questions about constants? Need more time on this slide?
Yeah, I had a question. So,
Okay.
are we supposed to write this one in this example?
Yeah, the first set that I had should have just gone under monomial. You can just circle them and draw an arrow.
Okay, I don't know.
So then you've got a space for non-examples. Do you see that?
Yeah.
Non-examples. So non-examples would be things that would have a variable in it. So non-examples would be things like 5y squared. Or 2x. Or if it obviously doesn't have a number at all, like yz squared. Okay, anything that's going to have a variable in it is a non-example.
So can we put with the variable?
Could you what?
Put with the variable?
Sure, yes, a non-example would be something with a variable. Questions, concerns, need more time?
We did this before I learned it.
Okay. A sum of monomials is called a polynomial. So mono usually means one. Poly means many or more than one. So we have a few different examples. Notice that in all of these examples, they are already simplified. There are no parentheses to distribute into. There are no like terms that we could combine. How many monomials are in that first example?
2.
2x and 3. How many monomials in the second one?
2.
2 again. 2ab is one monomial or one term. B squared is another one.
Isn't that a binomial?
We'll get to that in a minute. The last one has how many terms or
3.
monomials? 3 of them. Okay, so it's negative 6x, a 3y, and a 12z. What is the only constant we see in these examples? 3. So the only number that didn't have a variable attached to it was 3. That was the only constant in any of these examples. Questions about the difference between a monomial and a polynomial? Okay, we'll keep it moving. I think, there we go. Special names for certain polynomials. I shouldn't say monomials. These are polynomials. Because we have more than one term. A binomial has 2 terms. So on that last slide, the first one only had 2 terms. 2x plus 3 is considered a binomial. The one below it that said 2ab plus b squared only had 2 terms. That's a binomial. It could be all variables, so you could have x cubed plus y to the 4th times z to the 5th. That would be considered a binomial. A trinomial has 3 terms. So, negative 2x plus 3y minus 4z. 1, 2, 3 terms. Okay, so terms is usually another word we use for monomials. You could just have a squared plus b to the 4th plus c to the 6th. Okay, also has 3 terms. Notice that anytime I write these, there are no like terms still. Nothing that could be simplified. Questions about binomials and trinomials? How many people have heard those words before? A couple of us. Okay. Anybody need more time before we move on? On we go. In the monomial, negative 3xy, the numeral negative 3 is called the coefficient, or the numeral coefficient. That shouldn't be new. We've talked about coefficients before. The big number out in front of a variable. 2 monomials that are exactly alike, or are the same except for their numerical coefficients, are called like terms. Again, that's something we have talked about before. Oops, sorry, didn't mean to do that. All right. Example would be something like 2x and 5x. Those are considered like terms. Or we could have negative xy squared and 5xy squared. Those are also considered like terms. So as long as the variables and their exponents match, they're like terms. They don't necessarily have to have the same coefficient. Questions, concerns, or need more time on those? Okay, keep it moving. A polynomial is simplified or in simplest form when no 2 terms are similar. It's simplified after you have combined all your like terms. You ready to move on to that box on the next page? Okay. Oh, why? Let me look at your notes. Okay, these are a little out of order. Let's go ahead and simplify these real quick, and then we'll do the box. So these problems are below that box. You see where I'm picking up at? Mm-hmm. Okay. Let's practice these real quick. All right, on example 1, what can be simplified?
5x
Good. 5x and negative 8x can be combined. Remember to keep the sign right in front of the term when you do that.
Negative 3. No.
Yeah. Negative 3x is what we get when we combine those.
Plus 10.
The positive 10y does not change, so it is part of our answer. Questions about number 1? Okay, on number 2, what are two terms that are alike?
8 and negative 6.
Good. 8. Ooh.
Negative, I mean, positive 2.
12 and 4.
Okay, positive 12m and positive 4m are also alike. Usually when we write these, we would write them with the variable part first.
I didn't do that.
Okay, so 12m plus 4m gives me
16.
16m.
Plus 2.
8 minus 6 is a positive 2. So we'll get to that, I think, in today's notes. It's called standard form. Okay, so
The variables just make sure.
yes, variables should come before constants. All right, on number 3, what can we do to simplify this? Distribute the negative. Will any of the terms be able to combine? No, because they all have different variables. So distributing a negative means that all of our signs will change. 3a becomes positive. 10b is negative. 4c is positive. That's very similar to that warm-up problem we did. Okay, on example 4, what are two terms that could combine?
Negative 3x squared power x.
Okay, so the x squareds could combine. We have a negative 3x squared and a positive x squared. What does that combine to give me?
Negative 2
Negative 2x
x squared.
squared, very good. Okay, this is treated like a positive 1x squared. Remember, the variables don't change when all you're doing is combining like terms. What else could combine?
5x and negative 2x.
Okay, positive 5x minus 2x would be
3.
positive or negative?
Positive 3.
Positive 3x. So those combined, and what goes on the end?
Negative 4.
The minus 4 didn't have anything to combine with, but it is still part of our answer. Can we combine the negative 2x squared with the 3x? Why not?
Because that one has an exponent and the other one doesn't. Or it's standard.
You're on the right track. They do both have exponents, but they are not the same exponent, right? This one's squared. This one is technically to the first power. So they have to have the same exponents and the same variables to combine. Questions, concerns about example 1, 2, 3, or 4? Need more time. Okay. All right, now I believe we're actually back up in that box. The degree of a monomial is the sum of the degrees of its variables. We'll see if we come back to number 5. I didn't make this slideshow, so I'm just going with it. Do we have more on this? Nope. Do we get the degree of a monomial? Is the sum of the degree of its variables. So on those examples that you have there, peek over your shoulder, we've got 5x squared y z to the 4th. The degree of the variables would be their exponents.
2 and 4.
What's the degree on y?
1.
1. So the degree of a monomial is the sum of the exponents of the variables.
So it's 7.
So the degree on this one would be 7.
I thought it was the highest.
We're going to get to that. Okay, on that next one, we have negative 10 x cubed y squared. Is that z to the 8th?
Yeah.
Okay. So what would the degree of this one be?
13. What?
13. So we just add up the exponents. So here the degree is 13. Questions about the degree of a monomial? Remember, a monomial is one term. Even though there are multiple variables, we're just multiplying them all together. Need more time on this slide. Okay. The degree of a polynomial is the greatest of the degrees of its terms after it has been simplified. Okay, so we find the degree of each term and we use the highest one for a polynomial. How many terms do we have in this first example?
2.
2 of them. What's the degree of the first term?
2.
2. What's the degree of the second term?
0.
0, because it doesn't have any variables. So which one's higher?
2.
2, so the degree overall is 2. Use the higher one. How many terms do we have on the next example?
3.
3 of them. What's the degree of the first term?
4.
The middle term?
5.
The last term?
1.
Which one's highest?
5.
So that's the degree that you use. Okay, we went through those pretty quickly. Do we have questions about them? For sure? Need more time? Okay, we'll move on. Now this is way out of order from your... Next up in the box, a polynomial in one variable is in standard form. So those next 2 blanks should be standard form. When the exponents of the terms decrease from left to right, meaning your highest exponent comes first, and then it goes down one by one. So for example, something in standard form would be x squared plus 3x minus 5. Okay, highest exponent, next highest, none at all. Or something like y cubed plus y minus 5. It doesn't just have to have 3 terms, though. We could make it bigger. We could have a to the 5th minus 5a to the 4th plus 4a cubed minus 2a squared. Okay, as long as your exponents are going down, you don't even need to have every number accounted for. Notice on the middle one I went from 3 to an exponent of 1. But the biggest one comes first, then the next biggest exponent, then the next biggest exponent, all the way down. Questions about what standard form would look like? Okay. Next, when a polynomial is in standard form, the coefficient of the first term is called the leading coefficient. The leading coefficient. So it has to be in standard form first, and then the coefficient in the very front is like the line leader, the leading coefficient. So for example, if I had negative 8x squared plus 3x plus 10. What is the leading coefficient?
Negative 8n.
Careful.
There's second power.
Just negative 8. Okay, we don't include the variable at all. If we're talking about the leading coefficient, we just want the number in the front. Notice, though, that it was already in standard form. We've got a lot of vocab going on today. Do we have any questions so far about it? We're sure? Need more time? Moving on. All right, so let me go ahead and do your number 5 before we flip over. So your number 5 was just to simplify. Oh, they also wanted us to classify and state the degree. This is all out of order. We can go back to the other ones and do that. We're on number 5. Mn squared. Yep. M squared. 3mn squared. Okay. First step is to simplify it. So what can be combined? Negative m squared with 4m squared. Okay, those two can combine. That would give me what? What?
Negative 3. I mean 3m to the second.
Okay. Okay, and then these other two terms are also alike because they have the same variables with the same exponents. So when we combine those, we do get a positive 8mn squared. That is the simplest form we can get. So standard form we'll worry more about when we only have one variable. I'll worry about it a little less when there are two variables like on this one. So I'd be fine leaving this one here. We are going to classify the polynomial. So how many terms are there?
4. I mean 3.
When we simplify it, how many terms?
2.
2 terms, so it would be called a binomial. That's what it means by classify. They also want us to state the degree. So what is the degree of just the first term?
2.
The degree of the other term?
3.
So we choose which one?
3.
The highest one. So our degree is
3.
3. Questions, concerns about that one?
No.
Are we sure?
Mm-hmm.
Need more time on it? Ready to keep going? Okay. Now, let's see. Let's flip over and see where we're at. I'm going to borrow yours. Because yours is different than mine. Write it in standard form, state the degree. Okay, so I'm again going to change mine to match yours. And then we'll get to those other ones in a minute. So we're at the top of the last page. We're on your example 6. You see where we're at?
Mm-hmm.
All right, write it in standard form. For number 6, do we need to change anything for it to be in standard form? No, because there is only one term there. There's nothing to rearrange. So you would just copy it down in standard form. State the degree. What's the degree?
4.
How do you know that? Okay, it's the only exponent there. It's got a degree of 4. The leading coefficient I'm going to call the LC. What's my leading coefficient? -3. It's the only coefficient on that one. And the type of polynomial. How many terms are there? 1, so it's called a monomial. Do we understand what the directions are asking of us? I'll switch colors for number 7. Does your number 7 start off in standard form? No. Can any of the terms be combined?
No.
No, but we do need to rearrange it. What would it be in standard form?
9z minus 4
Careful. -9z
plus 4.
plus 4. Keep the sign that's in front of the term. So your original problem was 4 minus 9z. The negative sign is going to stay with the z. That 4 was technically a positive 4. Are we okay with that? So standard form, we decrease our exponents. So an exponent of 1 and then no exponent at all. No variable at all. State the degree. What's the degree of this one? The degree?
1.
1. Good. So our degree is 1 because the first term has a degree of 1. The other one has a degree of 0. We choose the bigger. The leading coefficient is -9. And then the type of polynomial, it is a binomial. Questions, concerns before we go on to number 8? 5x squared. So that is what your number 8 looks like. Is that in standard form? No. How do you know it's not in standard form? The exponents aren't in the correct order. We should always start with our highest exponent. So which term is that? 5x squared has the highest exponent or highest degree. Then what?
Negative
-x,
x.
and then
4. Add 4.
and then plus 4 because that 4 was positive. So this is my standard form. I'll put SF, standard form. My degree, I have to use the highest degree. So that would be 2. Very good. My leading coefficient,
4.
disagree. Why is it 5?
Is it because 5 is bigger than 4?
It's not because 5 is bigger than 4. Why did I have to use 5 instead of 4? 4 came first. When you put it in standard form. Okay, so make sure you're looking at standard form when you choose your leading coefficient. What about classifying it as a type of polynomial? Trinomial, because there are 3 terms. Questions, concerns? Need more time? Okay, let's talk about number 9. Number 9, they started you off with t squared minus t cubed plus 10t. Is it in standard form? Can anything be combined? No. So we just need to rearrange it. Which term needs to come first? Negative t cubed, then plus or minus? Plus t squared, then plus 10t. So biggest exponent, next biggest, smallest. This is considered our standard form. What is our degree? The biggest degree of all the terms, which is 3. The leading coefficient is what? What's the first term when it's in standard form?
Negative
Negative t cubed. So what is the coefficient on the variable?
1.
Close.
-1.
-1.
2. Oh.
The leading coefficient is -1. We consider it to be a -1 t cubed.
Would you cut it wrong if you just put -2?
Yes, because you can't have a variable as a coefficient. Coefficient has to be a numeral. Okay. What about the type? It is also a trinomial, 3 terms. Questions, concerns, needing more time, warm fuzzies, cold pricklies, void of all emotion. Some of you seem to be. Okay, we'll keep it moving. Back up. So these are going to be numbered a little bit differently than yours. That's fine. Looks like the problems are still the same. So I'll rewrite that one. This is really number... Wow, they've got numbered weird on your paper too. Do we all see where we're at? The second example 7?
Yeah.
Okay, sorry. I did not make this set of notes. I think whoever did tried to copy and paste from what we used to do before the new book. It's fine. The problems are the same. They're just numbered a little weird. Okay. So we all see where we're at. Next problem up. We are adding the polynomials, so you could put a big old plus sign here. What's nice about these first few, at least, is that they lined up our like terms for us. So we could just put that big equal bar like you would have done when you were adding back in like first grade. And we can just add down our columns. If we were to combine or add 6x squared and 3x squared, what would we get? 9x squared. Remember not to change your exponents. If you combine negative 3xy with another negative 3xy, what's negative 3 plus negative 3?
-6.
Negative 6xy. If we combine positive 2y squared with positive y squared, we would get
2y squared.
positive 3y squared. Can any of these terms be combined? No. We were also asked to find the degree. What's the degree? So what's the degree of the first term? The middle term? Careful. 2, because 1 plus 1 is 2. And the degree of this one is?
2.
So overall our degree is?
6.
Nope.
No.
Dominic?
9.
Nope. 2. You pick the highest one. If they're all the same,
It's 2.
it's just going to be 2. Okay, so to find each individual term's degree, you add the exponents. Exponents only, you don't include coefficients. And then to find the degree overall, you pick the highest one. But if they're all the same, they're all the highest one, it's just 2. All right, on the next one, again, they set up our columns for us pretty nicely. If we add 6a plus 4a, what do we get? 10a. If we add negative 4b plus 4b. Somebody said something.
0.
0, they cancel out. So you could just cross them off. You don't need to put plus 0.
2c.
Plus 2c. Okay, this is a binomial. What is its degree? 1. So the degree of each term is 1. So overall, the degree is still just 1. Questions, concerns about these two examples? Okay, ready to move on to the next couple? So this is really your example 9 again, right? 9. We are still adding these. They did not set it up nicely for us, but we could go ahead and just copy down adding that second polynomial and line up our like terms. That's not like. Okay, so the 9 is not like 2b, so I leave a blank space. If you wanted to fill in the blank space, what's the only number that would be appropriate to go there?
1.
0. We don't want to change it. You could put a big plus 0 in there. Are we all okay with why I moved the plus 9 down? It's not like 2b, so I don't want to confuse myself and add those. The other ones I could line up because their variables and exponents matched. Okay. When we add them, 2a squared plus 4a squared is 6a squared. Positive ab plus a negative 3ab. It's kind of like taking 1 plus negative 3. Negative 2ab. If I take 2b plus 0, I get 2b. And then what am I really adding to the 9? Nothing, or a 0, so plus 9. Questions getting to this point? Okay, what is the degree? 2. So our degree here is 2, degree here is 2, degree is 1, degree is 0. So the highest one was 2. Questions, concerns, need more time? Ready to move on? All right. The numbering is just a little off. This is your example 10 and 11. On number 10, did they line up our like terms for us? No, they did not. So if you want to rewrite it, you can, or you just have to be kind of careful. Okay, if we were to rewrite it, I'll rewrite the first one exactly the same. Is there anything that I need to line up under the 3x cubed? No, because there weren't any there weren't any x cubes here. The 4xy is going to go underneath what?
The 2xy.
The 2xy. So line that one up. Where is the minus 5y squared going to go?
The 3x to there.
Are those like?
No.
No. So if there's nothing like it, should I line it up under any of these things?
No.
No, so I'm going to shove it off to the end. So minus 5y squared off to the end. The minus 2 should go under the minus 9. Do we have questions about why I rewrote it that way? Okay. When we go through to combine, what's technically getting added to the 3x cubed? A 0. So that's just 3x cubed. 2xy plus 4xy. Somebody said it. 6xy. We just add those coefficients. Negative 9 plus a negative 2. We're just combining like terms. Negative 9 plus a negative 2. Negative 11. What's being combined with the minus 5y squared? Nothing, so it just stays minus 5y squared. I am not going to be as worried about standard form when you have multiple variables. So since we have both x's and y's, I'm not going to worry about it so much. However, we should still be able to tell the degree. The degree is 3. That's our highest degree of any term. All right, on number 11, are our like terms all matched up?
Yes. No.
Not really. The first one is the g to the 4th. Those are nice. But I would want the h squared to be under what? The negative 3h squared. And I would want the negative 10 to be under what? The plus 1. So on my paper, I'm just going to, or my iPad, I'm just going to scoot those down a little. So plus h squared minus 10. If I wanted to, what could I put in this big blank space I created? A 0. We again are adding our polynomials today. So if I take 7g to the 4th plus negative 2g to the 4th, what do I get? 5g to the 4th. We're adding a 0, which means that term isn't really changing.
So plus 2g squared h?
Careful. Negative 3 plus 1.
Oh, I see.
Dominic, what would it be?
Minus 2h squared.
Good. On the end, we have positive 1 plus negative 10. That would give me a negative 9. My highest degree is 4, so that's my degree overall. Questions on that one? We got one more. All right, last one. What's nice about this one? They're lined up for us already, which is kind of nice. We could fill in that blank space on the end with a 0 if you want to. If we take 8a plus negative 9a, negative 1a, you could just put negative a. Positive 10b plus negative 1b, positive 9b, negative 5c plus 2c, negative 3c, and on the end we would have plus 6d. Questions, concerns? What would the degree on that one be? A 1. They all have a degree of 1.